Welcome to the 5G track. For our next speaker, we have Tommy Williams, who's going to talk about the problem with 5G in construction, focusing on solution providers, challenging performance, new technologies, and strategies for overcoming excuses for the business. So Tommy is from Plinx. Welcome, Tommy Williams.
Okay. Okay, want to do any of that stuff? Hello everyone, my name is Tommy Williams and I'm the CEO and founder of Plinx. We're a construction technology company. We provide solutions that connect construction sites to provide sensors and wireless networks, and one of the wireless networks that we provide is private 5G. So today I'm going to cover the challenges relating to 5G connectivity from a solution provider's perspective. So we've heard some really good examples from Steve and Chris already about the contractor's perspective. I'll be covering why many performance enhancing technologies are relegated to the too difficult box, which is a term I'm using all too much at the moment, and therefore the missed opportunities for safety, efficiency, sustainability and compliance, and ultimately how improved connectivity could result in higher potential of delivery on time and to cost. So I thought I'd start with the reaction I get from most construction personnel when I try to talk to them about 5G solutions. And I think it really captures the current feeling about 5G within construction. And I'll go on to breaking down the various different reasons why I think that is the case over the coming slides. One of the things I think is very true is that we don't necessarily always understand the need of the construction site for the various different applications that are deployed, and really what this guy's expectations are for the services that he already uses. And that's something I really want to get into during this session. And as one of you already covered today, 5G was promised as this revolutionary solution to provide high-speed, ubiquitous connectivity. It's going to solve all of our problems, and it's going to be the future with drones flying all over the place and all that kind of good stuff. But actually, in reality, this is still what construction workers feel about 5G. So I'll go to talk a bit more about that on the coming slides. So as part of the exercise that we've been doing as the Commit to 5G group, we've started to map out how some of those requirements could be captured. And this is a real small extract really from that, but looking at what the variety of different metrics that we should be using, or the different treatments that we should be applying connectivity to, because it's not a one-size-fits-all solution. There will be a variety of different technologies that need to be used, and some will suit 5G and some won't. And so at the top here, we've got the quality of service and the variety of different metrics that we may use to define that quality of service. So we might be looking at speed, we might be looking at capacity, and we might be looking at latency. And some of the examples you gave about quality of connections working on some days and not working on others could be a capacity issue. But also you may need a really fast connection with low latency if you're doing a VR application, for example. Or you may just want to connect something just so that it pings a bit of data, string of data every 5 minutes. We really don't need groundbreaking technology for that. But we need to really understand that before we get into. So that's the what is important. And then we have the location, the coverage, the where is it important. Steve was talking about site-wide connectivity and how we can use, and how that's really important to enhancing and unlocking some of those productivity benefits. And so here I've just brought out 3 examples of how a construction site can be vastly, everyone talks about construction site, it could be it could be a bit of roadworks on the side of a road where it's a few ped barriers and a mini digger, or it could be hedges too, or it could be an underground tunnel, or it could be a large shed that's being put up for a data center, for example. They all have really different requirements, so they need to be understood and met. And at the moment, how we experience 5G in construction is that it's a one-size-fits-all. If you're lucky, an industrial router. If you're not, probably a consumer router. I recently went to a national highways project, quite a high-profile national highways project, where they've got really nice established offices. I think they might even have a gym in there somewhere. And along the edge of the offices, underneath the windows, were a load of mobile phones. I said, what's going on? Why are these mobile phones all on the windowsill? Oh, well, everyone's got their computers tethered to those because the Wi-Fi's crap in here. And I was like, we've got to get the basics right. You know, they spent hundreds of thousands of pounds on these offices. Nice bean to cup coffee machine, but the internet's crap. So that's really, so getting these things really important. So looking at the location. So just probably can't read it from back there, but I've broken it down to 3 different categories. So you've got off-site, and I've given some examples. So that may be your pre-construction teams, that may be ecology teams or your ground investigation teams. You might have logistics telematics that you want, stuff that's not really, it's not really an established site. It's something that's happening, you know, the odd person or the odd machine, and therefore it's not really related to a site environment. Then you've got a temporary site, so maybe the example of the roadworks outside where you know, you've got a few barriers, few people working around a site. It may be something up to a month's worth of work. And you may be looking at logistics telematics, you may be looking at connecting up a welfare unit somewhere that someone can go and connect hotspot, and then access the internet. And then you may have an established site. So this is, you know, offices with dedicated personnel that are on site. You may want to connect the compound outside of the offices, and then you may want to connect the whole site, as Steve mentioned earlier. So just taking out of, just focusing on the where right now, because I think we've done a bit of work as well to capture some of the requirements for each, for basically the list of the brainstorm that Steve showed earlier, the list of requirements for each of those for speed, capacity and latency. So let's just look at the examples here. So if a portion of this may be absolutely fine for public 5G connectivity, you may be able to accept a bit of loss of service because you can accept that there is no other solution to connecting it, and therefore a public 5G network would be good. And that's really what the disgruntled construction worker means when he talks about 5G. Then you may actually have another solution, an LEO, low Earth orbit satellite network, which can be set up really quickly and provides connectivity for the site offices and maybe a welfare unit. Brilliant, great solution. Then you want to expand it out a little bit outside of the site offices. You want it to be really ultra compatible. You don't need to go 100 meters. Brilliant, Wi-Fi. And then if you really want to connect the whole site, the only real solution, in my belief, is a private 5G network. You may be able to get away with Wi-Fi, but you're installing a lot of infrastructure in order to achieve the same result. So, I mean, definitely to me, but I guess from everyone in the room involved in innovation, it's pretty obvious that modern tools can drastically improve the performance of a construction project, but many of them rely on performant connectivity in order to the internet to do so, or they've been inefficiently developed to work independently. So really good examples of things like mixed reality headsets. A lot of them have processing built into them because, just as Steve mentioned, the chicken and egg situation, if the network doesn't exist, the solution providers aren't building devices to rely on the internet connectivity. And to give you a bit of background about me, I'm a product designer, R&D manager by trade. That's what I was qualified as. So I know all about product development, and I know that you wouldn't develop something if you couldn't rely on the solutions or the resources that it required. That would just be lunacy. So we've got this chicken and egg cycle here. I've called it the tech integration cycle, but I'm having second thoughts about that as I see it up on screen. But I'm going to give you some examples of the advantages of performant connectivity. So the first may be that actually, for the solution provider, you can reduce the cost of the hardware. So you may not need a quad-core processor in it, because all you're actually doing is streaming video and audio and depth data. And that may mean that the cost of this comes down, or it becomes a commodity, and therefore you can have more of these on site, and therefore you can reduce the frequency in which you need to be able to actually walk the route if what you're doing is scanning the environment, for example. You may, and if you're reducing the edge processing, you might be able to reduce the size and the weight. So it might go from something that's a whole helmet into a Google Glass, because actually what you're doing is you're taking down the compute requirement, the battery requirement, taking it into something that's much smaller form factor, and the cost and the size and the weight, and therefore the usability of it can improve. And also you may be able to make it more rugged. Things with big whirring fans and batteries, they're not ruggedized, they're not made for construction environment. We know that already. We're working on a project with a leading mixed reality headset company to actually miniaturize what the technology they've got based on the assumption that this technology works. And I'll come on to what we're doing in a couple of slides' time. You may be able to reduce the cabling or cabling complexities. So you may be able to say, right, this is a lower power solution, we can run it off batteries, so we no longer need to plug it in, or we no longer need to run a data cable. So examples of being able to put CCTV cameras anywhere on site rather than just where you can practically get a CCTV camera, or you may be able to just pick it up and move it because you're no longer bound by the constraints of whatever infrastructure is there. And then going back to a point that was raised at one of the earlier presentations about timing, enables field operatives to utilise more up-to-date information because they're no longer looking at a drawing that's out of date, and management teams to be able to access up-to-date information. To Steve's point earlier in the work we've been doing at Envision is all about, can we get this data in real time so that rather than the state of site getting back to the offices at the end of the day, not really useful until the next day if someone's remembered or can be asked to actually process it, we've got it immediately and we can do something with it. And then let's not forget that you could also connect remote teams. And remote means two things. It could mean remote on a site, could mean I'm an archaeologist and I'm working the other end of the site and I need to be able to get information back, or I may be able to call for help even. Maybe I need to pick up the phone and make a call. We've got a security problem, we've got a fire problem, we've got a first aid problem. But it may also be remote people that are working from home who want to be able to dial in and see what the state of site is. There's no point in them dialing in or connecting in if they're looking at data that's 2 days old. So this is all about collaboration and being able to connect information. So the benefits are definitely worth having, and just give it, and the chicken and egg example is really good. So, but I think we're still facing two problems. The connectivity needs to be good enough, which is getting there. Last year we made huge step forwards in the private 5G space in terms of the standards evolving, Ofcom actually issuing us with licenses in a timely manner. Quite a stressful experience, but they're making that a lot easier and opening up the spectrum so you can actually just buy a small snippet of land rather than needing to pay multi-million-pound deal for the whole country. So that solution providers, performance-enhancing technology providers can do their thing. But also the value case, which Steve also mentioned, needs to be demonstrated to warrant both the investment in the technology, but also the investment in the network. And then the value needs to be leveraged for both the solution providers and the networks providers. Now, I'm in a fortunate position because I'm talking about sensors and networks. That's what we do. So that's easier to realise. But there is a problem when someone comes to Plinx and buys a network or rents a network, and then all the added benefits of the other sensors and solutions that are being bolted on top of that. So that's something that's really, we haven't really got to the bottom of at the moment as we stand. Excuse me while I just... Steve mentioned that we're building a business case and a value case, and we're breaking that down. We're doing the current at the moment, aren't we, Steve? We're doing, what can we currently realise from, and we're focusing on productivity gains as the tangible benefits, and then there will also be intangible benefits as well, though we won't be including them in the value case in terms of return on investment. But the other thing that we want to do is to look at the future potential. So if this plays out and the connectivity does everything that it says it's going to do, what will we see changing in this space, and then how will that impact? So an example of the 360 cameras, there isn't currently a solution to upload the information automatically from a camera, but we are now in discussions with 360 camera providers to say, if this happened, if the connectivity existed, how would you move that forward, and then what then benefits could be leveraged. So there's a sort of two-stage approach there. And even with a solid business case, the operational model, which is something that most people forget about, still needs to be there, which supports the utilisation of the technology properly, promotion of the technology's capability within organisations. So that requires some education from IT and OT departments within construction companies themselves as to what is actually possible. Bearing in mind that there's limited technical capability on site, construction teams are already time poor, perhaps because they're wasting loads of time walking around site, as I'm probably learning from today. But the deployments need to be really easy, and otherwise we're just going to, the product that's created, the products utilised needs to be really easy, and only then will we see it move out of the too difficult box. So just to sum this bit up, contractors need to rely on solution providers to make the technology easy to adopt. It needs to be plug and play, and they need to work with collaboratively with contractors to develop the operational model. And that's the bit that I don't think has been done so far. There's been a lot of trials. We've been involved in many of them. Work you mentioned earlier in Shetland, some of the work that's been done in London. But the operational model really hasn't been considered. How this technology integrates with the IT departments, that's still not something that's really been supported. And then going back to the earlier example where I showed multiple different technologies, how do all these plug together? Where's the menu? How do we pick from which ones we're going to use and how we're going to use them? All that good stuff. And only then really can we move forward. So that's that. I've spoken quite a lot about public and private 5G. I want to keep this really nice and light without getting into the details, but most people, public 5G is essentially what you have on your phone. It's provided by the 4 network providers that Steve flagged up on a slide earlier. And the evolution of the 3GPP standard now means that you can have private standalone 5G networks, of which that's what we provide. And this is a really quick matrix just to show that obviously there is additional benefit. There is additional investment required in order to have a private 5G network, which is the core advantage of using a public network. You don't need to stand up a mast. You don't need to stand up a backhaul solution. You don't need to manage it. You've got all those advantages. There's further investment, but you also aren't sharing your bandwidth. You're able to customize your coverage to ensure that you've got cross-site connectivity, and you have no data limits. You really are in complete control of your network. It's private, as it says on the tin. And there's this sort of like point where everyone says, oh, the 5G networks are too expensive. And sure, but it's like saying cars are expensive. You can have a Ferrari or a Fiat. They're complete opposite ends of the spectrum. So this conversation really should be about what can we accept? What do we need? Do we need a Rolls Royce, or can we use a Mini? It could still be private. It could still do everything we need. If we go back to the requirements capture on a few slides ago, once we really understand that, what's required on a construction site, we can build a suitable solution. So it won't be too expensive, and it will address some of the issues that are already out there. It's also worth pointing out that historically these private 5G networks, they were bespoke. They were a kit of parts that were put together. They were designed specifically for a project. That isn't the case anymore, or doesn't have to be the case anymore. These bespoke networks were really expensive and they came with huge technical burden. That also doesn't have to be the case anymore, and I'll come on to that going forwards. So I believe, trying to pull this full circle, that the disgruntled construction worker right at the start of this slide deck is not able to differentiate between public and private 5G. They probably don't even know it exists. And why should they? They don't really care. But one of the really important parts is that we want to be able to provide this solution to them without getting that immediate response, because otherwise we're never going to move things forward. So there is a bit of marketing if I'm talking about problems, we need to understand how this works in terms of how we can continue to promote private 5G as a solution without it getting pigeonholed in the, yeah, that's crap, that doesn't work wherever on any sites. Any sites I've been on before haven't had good enough connectivity. This is an extract from some of the business case work or the value case work that Steve and I have been doing. And this is really about understanding the impacts of services. So the accessible services and the resulting benefit, split into tangible and intangible benefits. The tangible benefits are the things we're measuring. The intangible stuff is other advantages that you get, other benefits you get of using a system like this. Plinx generally works on resource-heavy projects, large infrastructure projects, and so the solution I'll introduce in the coming slides is able to tackle some of the shortcomings. A recent business case identified a return on investment of 5 times. So 5 times based on the cost of the network and then the resulting benefits. So just going back to the point earlier, it really doesn't have to be too expensive. And we are working on the value case, which hopefully we'll be able to share a high level version, Steve, at some stage, that really starts to tackle this and questions, is it really too expensive, and can we get the performance that we need? And really understanding that. So there's a much bigger mapping exercise that's gone on, and this is just a couple of extracts. So I'd like to just introduce the Plinx system. So from a performance perspective, we first launched this in November last year. We've collaborated with a number of lighting tower companies, and our objective was to make something that was very quick and easy to use. So the networks can be popped up in 3 minutes, so total location and active in 3 minutes from the moment the tow hitch is dropped. We get 300 megabits per second over 3 kilometres, and that's run completely off grid, so off solar power and the battery storage unit inside. As Steve mentioned, we are now fitting a small motor to that to cover things like if the panels get dirty or if it's incorrectly positioned, to ensure continuation of service. We also are working on a faster version of this, though. In our experience, the current offering of 300 megabits per second far exceeds what you get from any sort of public network, and that's scalable with a number of connected devices. 750, I think, is our max at the moment. So what have we done? So it's proprietary low power configuration, enabling full function from solar and battery. So the clever bit we've done is the power saving mechanism, proprietary power control and core, which enables us to run at ultra low powers. So we stick on the solar panel. We have a pre-approved device list with support for iPhones after a certain generation. I can tell you which exactly those are. Android devices, industrial routers, and network devices. So network devices could be 5G CCTV cameras, for example. Industrial routers, we have a whole range, iPhones. So we can provide you with a list. You can buy them from us, or you can go and buy them direct. And we also have a mapping functionality in a platform. So you can use the GNSS system within the device to say, I'm putting the network here, this is the expected coverage. And within that, you can bring in a 3D DTM model. So you can really start to understand, this is the elevation profile of our site. This is the kind of coverage we can get just from that. So this is about ease of use. This is about, I don't need to do anything. It doesn't need to be connected to the mast. So there's a quick release hitch here, and then that can be bolted onto the top of a cabin. We've got an ISO container fix and mount and things like that. But yeah, easy to set up. It's provided on a rental basis with no capital commitment, and it includes SIMs and data, a limited number of SIMs. I think the first offering is 50 SIMs, and they can be eSIMs, electronic SIMs, and the data, and optionally with pre-provisioned devices. So you can have that with a box of smartphones or a number of iPads. It's 100% off-grid. So as I said earlier, you tow it to the location you want it to be, through the remote control, you deploy the mast, and once it's powered, it sets itself up It has, within the system that we've developed, it understands where other masts are, and then it provisions the network accordingly. So this is all about changing as the requirements of site change. It's a self-contained unit, so this is the first time it's actually ever been seen. This is still a CAD model, but this is the finished product. So it's a self-contained, ruggedized unit, waterproof, so it can be jet washed. It can be used in dusty environments. It's standard, so they're all the same. It can be mounted onto the mast with a quick release hitch, and it's been designed to be mounted within site regulations. So we've considered things like on-site risk assessments and some of the barriers that we've had so far of getting this technology on site. It's no longer, is it, something that is, what the hell's that? It's right, this is exactly how you get onto site, turn it to this location. It works in construction environment. If I need to service it, we've thought about that already. And it's modular. So that all the networks, all the devices are the same. We're no longer looking at bespoke networks. We're no longer looking at needing different antenna setups, needing different processing setups. These can be towed around and they mesh with one another, which means that they can communicate directly with one another and other devices that are within the network. And you can roam seamlessly. You wouldn't notice, you'd be able to move between masts and you wouldn't notice. And this is all about ease of use. That's what we're really focused on, and being able to do that. They can be obviously arranged in a linear form or various different other shapes. You could deploy one of these locally to an area of site. Say, for example, if you're working on a roundabout, you could position this at a roundabout site as a remote connectivity. You don't need them all to be joined as it's shown on the screen. So a quick summary, there is no one-size solution for connectivity as it currently stands, though there are, and all of the solutions that we've spoken about today should be considered. I should have put 5G isn't crap, actually, but I've just realised that's a missed opportunity. The technology exists to solve our challenges, so from a performance perspective, we need to consider what they are. And there's a balance to be had, but speed, capacity and latency, and then also coverage. So we need to consider what that is, but the technology already exists to be able to solve those issues. The responsibility needs to be shared between contractors and solution providers, and that's to ensure that we develop suitable products, we educate teams about the capability of public and private network and where it should be appropriately used, and also really key, development of the operational model, the thing that actually supports this once it gets onto site, so that it's not just delivered, set up, and then expected to work. That's not how the construction industry works. We need to be careful what's promised and how we name our products. So we can call this lightning fast 5G if you want, but I think we're setting ourselves up for some potential failure if those expectations aren't met. And the significant performance enhancement and value can be leveraged. I think there's really some interesting facts about productivity in your slides, Chris. I was quite pleased that, I don't think we've seen each of the slides, but I'm really pleased that there's some common themes going through them. That's good. And also we have a solution. So hopefully that's been interesting. Happy to take some questions now, or whether we want to do that in a moment.
Great. Very much, Tommy, and I think you're right. There have been some huge, very public 5G disasters. So it is up to us to kind of rejuvenate the industry into thinking about the next phase of 5G and how we can really fix that publicity issue that's happened in the past. So we're doing a Slido now, aren't we?
We are.
Yes, we are. So your turn to agree or disagree. I don't know if I have to end that one and start a new one, maybe?